Our next topic is your multiplexer and demultiplexer. So now can anyone tell me what is multiplexer? So in the multiplexer, basically, as the name suggests, multiplexer, there are multi inputs and the single output in the multiplexer circuit, right? While in the demultiplexer, there is single input and the many outputs, right? So this is also your one combinational circuit. It is also called the, in simple form, it is also called the mux, right? The alternative name of this multiplexer circuit is many to one. It is also called the many to one circuit, means there are the multiple inputs and the one output, right? Means it act as your data selector. It is also called the data selector, means this circuit will select the input data, which input have to propagate it to the output, right? So it is also called the data selector, means if there are multiple inputs, only in one particular combination only one input is propagated to the output, right? So that selection is done in this multiplexer circuit, which input is propagated to the output, right? So one more important thing, it is also called the universal logic circuit, not universal gate. Universal logic circuit means the other gates and any logic can be designed with the help of multiplexer. When we discussed about the adder, then I told you some questions. How many multiplexers are required to design full adder? How many mux is required to design the full subtractor, half subtractor and the half adder, right? So now after discussing this multiplexer circuits, you can answer all those questions, right? So it is also called the parallel to serial data converter circuit, means it convert your parallel data to your serial data, right? So now see, these combinational circuits also we can design with all those steps. First, we should know what are your inputs and the outputs, right? Then you can draw the truth table and then you can find out the Boolean expression of that. And then finally, based you can minimize that expression and finally you can draw the circuit for the same, right? So, in general, multiplexer is defined in this way, or multiplexer block diagram is shown in this way, right? So these are your inputs, right? So here I am saying M is equal to, these are your M inputs, right? M inputs, clear? And then there are also some inputs, these are basically called your select lines. Select lines. So basically your select lines defined, or select lines tells you which input is propagated to this output, right? So it is also called the M into 1 mux, means if there are the 4 inputs, then it is called the 4 into 1 mux. If there are the, always this inputs is in this ratio or in this proportion. If there are the two select lines, then your inputs, number of inputs lines should be 4. If there are the 3 select lines, the number of the inputs lines should be 8, means 2 to power that select lines, right? So n is your select lines, clear? N is your select lines, clear? So in another words, if we can say the 4 into 1 mux. What is the meaning of 4 into 1 mux? There are the 4 inputs, right? I0, I1, I2 and the I3, right? Only and these select lines will select these inputs, and based on that any input can be propagated to the output, right? So we will understand this thing in the next by taking examples of 2 is to 1 mux, 4 is to 1 mux, right? So the basic symbol for the multiplexer is the symbol. In some books the symbol is given for the multiplexer in this way. These are the special meaning, right? You can't make this symbol like this. You can't make the symbol like this. It is wrong, right? So these are the special meaning, means the inputs should be high. So that's why it is merging like this, right? So it is data inputs. These are your select lines, right? So these are your select lines. And this is your output, right? If we are saying 4 is to 1, then if we are saying 4 is to 1, in that case, the block diagram or the symbol for the 4 is to 1 mux is, these are the two select lines and these are your 4 inputs. So it is basically your 4 is to 1 mux. Select lines, right? Now understand the meaning of your multiplexer. Understand the meaning of mux. What is the meaning of mux? Right? Now we will discuss 2 is to 1 mux, or we will design our next combinational circuit, that is your 2 is to 1 mux. So 2 is to 1 mux basically. Now first of all you should know how many inputs and how many outputs. Now can you tell me into 2 into 1 mux how many inputs are there and how many outputs are there? 2 into 1 mux. 2 inputs, right? And how many select lines? 1 select lines and how many outputs? 1 output, right? So inputs I am denoting this I0, I1, right? This is your select lines, right? Clear? Now tell me. Okay, now first step is fine. First step to design this combination circuit, you should know the number of the inputs and number of the outputs. Now next is the truth table. Now there are the this one and this one, right? So the truth table of your mux only involves your select lines and the output, right? Because you know the basic definition of multiplexer, these inputs should be propagated to the output based on these select lines, right? So if S is 0, if the select line is 0, then this I naught is propagated to the Y, right? For S is 0. Clear? And for this S is 1, this I1 is propagated to the output for S is 1, right? So if S is 0, what is the output? Output is I, right? And if S is 1, what is the output? 1, right? So what is the logical expression for the Y? Can you tell me? What is the logical expression for the Y? S bar into I naught plus S into I1. This is the logical expression, right? This is the logical expression. No? In this expression, you can put if S is 0. If S is 0, what is the Y? In this expression, put S is 0. I know if S is 1, if S is 1, Y is 0, right? So now what is the logic circuit for 2 is to 1? What is the logic circuit for 2 is to 1? This is your AND gate and this is your OR gate, right? So This is your means this logic circuit is there. So what is this? This is I know, and what is this? This is your not gate, na, right? So this is S, this is S bar, right? And second AND gate, and the second AND gate S is there, and what is the second input? I1 is there, and this is given to one OR gate, this is here, right? So this is the internal circuit which is inside this 2 is to 1 box, right? Clear? It is very easy, right? Similarly, can you design into 4 is to 1 marks? Okay, I am giving you the example also 4 is to 2 1 marks, 4 is to 1 marks. So into 4 is to 1 marks, how many inputs are there? 4 inputs. Select lines are also inputs, right? But here, don't get confused. Input means these inputs and select lines we are saying. But in some books, it is also written select lines is also your inputs, right? So output nahi hai because these are only, there are two categories, inputs and the outputs. So how many select lines are there? If there are the 4 inputs, 2 select lines, right? So 2 select lines and 2 to power 2 and 4 inputs, right? So these are your 4 inputs, right? So what are those 4 inputs? I0, I1, I2, I3, right? And what is the output? One output, right? Now, next is your truth table, right? So, your truth table means your output depends on only these select lines. Which output will be propagated to the, which input will be propagated to the output. Now, if both are 0, 0, both are 0, 0, it means what is if the, if in general, also in another words, you can learn this thing, right? If select lines is 0, 0, it means what is in decimal? It is 0, right? What if the select line is this 0 and then 1? Then in decimal, what is it this in the decimal? It will represent 1, na, right? And if it is 1, 0, what it represent? If it is 1, 1, what it represent? 3. Right? So in the similar manner, these inputs are propagated to the output, right? When both these select lines are 0, 0, I0 is propagated to the output, then I1, I2 and the I3. You can also learn this thing from this. Understood? Right? Clear? Now the logical expression for the Y. Can you tell me? S naught bar, S1 bar into what? I naught plus S naught into S1 bar, right, into I1 plus S1 S naught bar into I2 plus S naught S1 into I3. Don't get confused. This S naught should be your LSB, right? Don't make it the MSB. Okay, if you are making it the MSB or LSB, then you have to mention. If there is a, if you did not mention anything, it means it is understood that this S naught is your LSB. If you are making S1 as LSB or any other thing as a LSB, for example, any other digits to represent, for example, you say I will represent sir with S2 and S3, then you have to mention this S2 is your LSB and this S3 is your MSB, right? Clear? If you are taking the serial order, then it is understood. Clear? Then can you design the circuit for this? Logic circuit for this expression. How many AND gates this circuit have? 3 inputs. How many? 4, no? Right? And there are the 2 NOT gate, right? These NOT gates are for S0 and the S1, right? And the output of all these AND gates is given to which gate? Your 4 into 4, right? So here, what is this? What is the 3 inputs? I naught, S1 bar, and the right. Clear? Also, you can connect this thing here, right? Clear? So what will come here? I1, S1 bar, and here S naught, right? You can connect here S naught. Similarly, here the I2 will come and S1 will come. So from here, or you can write here S1 and here S naught bar. Similarly here S naught, S1 and the I3, right? So this is your internal circuit for 4:1 Mux, right? Clear? So in the similar way, you can design the higher order of mux, 8:1 mux, 16 into 1 mux. So it is also asked in the objective type questions in 16 into 1 mux. How many select lines are there? Right. In 256 into 1, how many select lines are there? Right. In this way, this 2 to power n should be your 256. So from here we can find the n. Right? Clear? So students, if you have any doubt related to this topic, then you can send me a mail or you can contact me directly. So for more video update, please subscribe this channel, fine, so that every information regarding your course or regarding this digital electronics lectures you can get easily. Fine. Thank you for your attention.